Hello, this is Mrs. Pullen for AP Statistics. In this video, I'm going to go over a couple of problems from the Unit 6 review sheet. I'm going to start with number 1. Here we're given a random variable x and we have a probability distribution represented in the table on the right. This is a discrete random variable. How do I know it's a discrete random variable? Because I only have values 0, 1, 2, and 3. There are no gaps in between. There are gaps in between. So you can't have a value like 0.2 or 0.5 or 1.5. Okay. The goal is to find the probability that the random variable x is less than 2. But if you look at the probabilities associated with each outcome, they're represented in terms of the variable k. So the first thing we need to do is find out what k is. Now we know that the probabilities have to add to 1 to be a probability distribution, and that's going to help us. Because what I can do is I can sum all these probabilities together and set them equal to 1. And I have this mini algebra equation. So this is 5k plus 13k is 18k plus 2k is 20k. Divide both sides by 20. You have k equal to 0.05. And then now we can determine the probabilities. For 0, that's 2 times 0.05 or 0.1. For 3k, that's 3 times 0.05 or 0.15. For 13k, 13 times 0.05 is 0.65, and 2 times k is 0.1. So we want to find the probability x is less than 2. So we would just simply add the 0.10 and the 0.15 together to get 0.25. And that's choice B. Problem number 2, you're given a table that represents the number of tickets that customers can purchase, and they can purchase anywhere from 1 to 5 tickets. And we're told that each ticket costs $12, and they said based on the distribution, what's the mean cost for the performance? Well, the key thing is mean cost. So there are a couple of things you can do, but probably the easiest is to get the mean number of tickets purchased. So the mean number and expected value are the same thing. And there's a formula on the formula sheet that says take each of the outcomes and multiply it by the probabilities and then sum them together. Now, you certainly can do this by hand, or I preset up my calculator. You can enter the outcomes into a list X and the probabilities into a list P. Hit Control Page, add a calculator page, and hit Menu, Statistics, Stack Calculations, one variable statistics, one list, X for the X list, and for the frequency you enter P and you hit OK. And we scroll up, and here we have a mean of 2.45. I don't need the standard deviation, but it's there as well. And then because I want the cost, you're going to multiply 12 times 2.45, and that gives you $29.40. For problem number 3, you're told that the mean of a set of scores is 70.3, and the standard deviation is 8.8, and now they're being scaled, by the following equation. And we don't have the raw values, but from that equation and the old mean and old standard, or original mean and original standard deviation, they want you to find the new standard deviation. Well, if I was asked for the new mean, you would just substitute in. You would go 0.7 times 70.3 plus 30. They didn't ask for it, but if they did, that's how you would do it. And you would get 79.21, but the standard deviation is only affected by multiplication and division. So that's why, I don't know why I did that. That's why you would take 0.7 times 8.8, and that's where the 6.16 came from. And I'll do one last problem on number 4. You're told that airlines have to be aware of the weight of the aircraft, and they collect data on 4 types of random variables: the plane, the people, luggage, and fuel. They said to make the assumption that these random variables are independent, and they want to create a new random variable, t, which represents total. And they want you to find the new standard deviation. If I was asked for the new mean, because it's independent, all I need to do is just sum them together. They didn't ask for it, but if they did, so that would be 75 tons. But the standard deviation, when you're combining, as long as the variables are independent, is the square root of the sum of the variances. And that's the square root of 6, which is 2.45 tons. See you tomorrow. Have a great day.